and welcome to this introduction of our ultra-low power workshop for the Internet of Things. A 2-day interactive hands-on workshop. Wouldn't it be great if your device could work without batteries? Wouldn't it be nice if you could comply with international demands regarding energy consumption of your products? If you can live longer on your battery than your competitor can, and if your device's energy harvested was a match for its requirements in terms of energy. So, are you looking to work on a mobile connected device? Are you under pressure to reduce the energy consumption of your products? Are you developing a new product that really requires ultra-low energy consumption? Then this is a place for you. We're looking at the IoT edge node in particular, which is wireless and really requires ultra-low power. But also many of these techniques can be used in other contexts because the principles remain the same. If you want to know what your options are, if you want to know a little bit more about this energy and power management, then you can have a look at all these different factors that have an influence on this energy consumption, where it is critical that you understand that all of this is built on trade-offs between disciplines. You cannot do it as a software guy alone, you cannot do it as a hardware guy alone. You need to talk, exchange ideas and come to the compromise that gives you the best results. So if we are looking at this thing, then we have to understand system is the word. The possibilities, what we can achieve, they are determined by the hardware that we have. And if there are no settings that we can control in the hardware, then there's no use for the software because it cannot control them. And if the hardware does have energy saving possibilities, the software should know about them, understand them and actually use them. Otherwise they are there for no reason and they just cost money. So this workshop identifies many factors that influence the energy consumption of your system. It explores the energy saving features of energy aware MCU families. We talk about how to model and measure energy consumption and provide an overview of available energy measurement tooling so you can see what's working. And to help understand this, we have hands-on sessions using different MCU family boards to anchor the knowledge that we have. So this is an example of such a board where we have this energy measurement integrated in the development environment. So you can see immediately what the results are of the ideas you have. You can implement them and directly see what happens to your power consumption. So it's really very useful tool to get to grips with all the features and see, are they usable for me or do they not add anything. We'll talk about the interactions between hardware, software, compilers, optimizations in various forms, and discuss the influence of the different possible software architectures on your consumption. We'll talk about energy harvesting, about energy storage, battery technology, and the chips to help you manage your energy, the power management ICs. And we'll also go through some real-life energy optimization use cases. We'll demonstrate and discuss some energy consumption benchmarking scenarios and see how we can improve the benchmark scores by doing some optimizations in different areas. So we look at infrastructure and we'll tell you, okay, what can we do, what is available, how can you use it, how do you create your software to use all these features. So in the end, we provide you with an understanding of all these relevant factors contributing to energy consumption. You will understand what kind of mechanisms are available that can be used to reduce this energy footprint. We'll talk about a way of working to tackle your energy related issues. And of course, we'll tell you, okay, these are things you could consider if you want to improve your power consumption. And there's plenty of opportunities for you to ask your own questions. We have the whole hands-on sessions for this as well. So while you're working, you can ask the questions, and maybe your fellow attendees have some ideas about things. So when we're looking at some evidence that this power management is really important, we can already see that many modern operating systems provide a power management API. For instance, your own laptop, your PC has a specific API, the ACPI as it's called. And many chip makers also compete to minimize the energy consumption using power management hardware features. But again, the software must then actually use these features. They have to understand when to use them, what these features actually mean, so that you can get a better product out of it. So what we aim with this workshop is that you understand that ultra-low power is a system thing. To understand that hardware and software mechanisms for energy management have to work together. You have to understand what they do, so you can actually apply them in the way they were meant and help you in your quest for low energy. And it's also understand energy harvesting concepts. So you can see, okay, what kind of energy can I expect to be using? How much energy can I get from this technology? So you don't get overexcited about some of these possibilities. What we do is we provide an overview of many factors that influence energy consumption. So we look at energy savings mechanisms at all system levels, hardware, software, board level, lots of different places. We generate practical assignments with real ultra-low power hardware in teams of 2 or 3 people, and we try to match up some junior with some media or senior so that nobody gets left behind in the process. We do a demonstration of energy benchmarking, and we discuss several real-life use cases, see what did we do and how did it help. The audience for this workshop is somebody doing IoT development, an embedded hardware engineers, embedded software engineers, system architects, project leaders in engineering and R&D. So what basically do you need? Some working experience with Windows 10 or Linux or iOS, with the ability to read and modify simple C programs. Your development environments you can install before the workshop and then use. They're available on all these platforms, but we basically prefer the Windows 10. The program consists of lectures. So we have a lecture about power management is a system issue, static versus dynamic power consumption. We have techniques for the reduction of power consumption. We give you an overview of tools for energy measurement, whether or not they are integrated in with the IDT, which some of them have. And we talked about the energy sources, the harvesting, the storage and the retrieval. What can you do to make your charge last as long as you want, or as long as possible. And we also talk about some more lower level things, direct memory access. How does that help you to relieve the CPU from work? We talk about the MSP430 architecture and what kind of architecture influence you have on the way you can optimize your code. We talk about energy efficient coding, discuss IoT radio technologies in relation to energy consumption, talk about how can we interface with sensors in an energy efficient way, and we'll talk about the Embassy, the microprocessor benchmarking consortium, embedded microprocessor benchmarking consortium. Then we do some sessions on real hardware, ultra-low power hardware, so we look at energy profiling, energy modes with the EFM32 architecture, and energy reduction with DMA. We provide energy profiling examples with MSP430. Lots of evaluation of coding influence on this energy consumption. And we have a demo of what we can do to optimize a benchmark, an embassy benchmark for IoT and security. About use cases, what can we do in a simple case to optimize the copy speed of memory but by a factor of 12, improving the secure benchmark by a factor of 9, and we don't actually change the code, we just change all sorts of environmental factors. So what do we get out of all this? We get a process for applying these power management techniques. You have to get between the ears. Power management, it's a system issue. So get to understand modern energy efficient microcontroller architectures. Get to know the hardware features that are available to reduce the energy footprint. What kind of tools can you buy to help you measure your energy? And what can we do in terms of possibilities to get a successful implementation of low power targets in embedded systems. And also we get an interview, a view of identifying the critical ultra low power system parameters that you can find in the various microcontroller families. So the workshop itself, it's 4 half days of lectures, exercises, use case and demos. It's an online workshop. You get a list of hardware to order 3 weeks in advance so that you will have the hardware. So for the next setup session, we do the setup before we start the workshop so that we can spend all the workshop time on actually doing workshop exercises rather than setting up your environment. You have an experienced lecturer at your hands. I'm an advanced expert at Capgemini Engineering. I've worked for a lot of different big and small companies over the years in all types of roles. So as automotive, ultra low power expert, troubleshooter, whatever. You're in good hands. And let's hope that this helps you to understand this is the workshop you need. And hope to see you in the next workshop installment, the next workshop around. Thank you for your attention.